So today we're going to be investigating a data set that contains a sample of 300 vehicles that were sold in the United States in 2015. And we've opened our data set here and we can see all the different variables we have, from the division, the type of car that was made, engine displacement, cylinders, miles per gallon, types of transmissions, what type of fuel it uses, fuel cost, whether or not the vehicle is a hybrid. So we have a lot of stuff we can work with here. And for today, it's important to have an idea of what engine displacement means if you don't know what that is. And I understand it as the distance inside of an engine that a cylinder travels up and down to produce the spark that makes the engine go. So the higher the displacement on the engine, the farther the cylinder travels, the more fuel that is consumed in one stroke. Okay? So since engine displacement can be related to fuel consumption, I think a good way to start is to look at the relationship between engine displacement and, let's say, our city miles per gallon. So I'm going to add two graphs here just by clicking the graph button up here twice. I have two blank graphs, and first let's drag engine displacement to the x-axis on this one, and again to the y-axis on this graph. Okay, so we see the same information but oriented differently. Looks like the middle of our engine displacement data is around 3 to 4 inches. Okay, somewhere in here seems to be the middle, with a slight skew to the right. We got a little more higher values than we do lower values. Okay, now we can take city fuel economy from our table and drag it to the y-axis here, and again down to the x-axis on this graph. Okay, so just to prove that these are showing us the same information just in different ways, I'm going to click on a random point here, and let's see what it tells me. It tells me I have, for this data point, a fuel economy of 22 miles per gallon, engine displacement 2 inches. And then it has highlighted the same point in this graph, which tells me the same thing. Engine displacement of 2 inches and a city fuel economy of 22 miles per gallon. So these two graphs are telling us the same information with the variables on the different axes. And we can see from both that there's a slight negative relationship going on. So as engine displacement is increasing, we can see that our fuel economy starts to go down a little bit. And I want to keep working with both graphs for just another moment. So if we could come down to the bottom one, we're going to start here. Click on the ruler on the menu. Click on movable line. And now we have this line that we can manipulate, just like this, to line up with what we think is a good representation of all of our points. So we're just going to pick a line that seems to represent the general trend of all of our points. So that looks okay to me. It doesn't have to be exact, we're just guessing. And we're going to come up to the first graph and do the same thing. Add a movable line, and we're going to shift it around a little bit, just so we can get an idea of what our graph is doing. Alright, that looks pretty good right there to me. Alright. So now I want to add what's called a linear regression line. So this is going to be the average line of all of my data points. So it's the line that maximizes, well, not maximizes, it's the line that minimizes the distance that all of my points are from the prediction line. So it's the absolute best possible linear line that represents all of our data points. So we can click on the ruler, click least squares line. Let's do the same thing down here. And now we can see how far off our prediction is from the real prediction. Alright, so up here it seems that we predicted a little too high, but a decent slope. This one was negative 3.6 and the actual was negative 3.24. And here we had negative 0.19 and then the actual was negative 0.17. So that's good. Now let's go ahead and take off our movable line so we can get a better picture of the least squares line. Okay, we'll just click it off just like that. Now we can see in the top graph that we have a slope of negative 3.24 here, And it looks like our data is going down just like that, pretty smoothly. And down here we have negative 1.7, but our axes are arranged in a way that it looks like we're getting an even steeper slope. But it doesn't even matter, because what I really want to show you is that if we click down here on the yellow part, I can prove that these are the same because of our r squared value. Our r squared value is the measure of the variability we can expect as a result of our predictor variable. And it is an estimate of the strength of our relationship. And in both graphs, they are 0.55. So this tells us we have a pretty average relationship between the variables, and that these graphs are telling us the same information. So since they're telling us the same information, we need to decide which one to use. Now, in the context, a manufacturer of vehicles has the ability to change engine displacement, right? But they don't have a machine where they can add screws to the miles per gallon box and get a better miles per gallon. They're going to design engine displacement to achieve a miles per gallon. They're not going to design miles per gallon to achieve an engine displacement. So that's why I think that we should be using this top graph, because we have engine displacement on the x-axis. So based on our engine displacement, we can predict after that what city miles per gallon we can expect. So let's go ahead and delete this bottom graph, okay? Now I want to investigate my data even further. I want to look at if there's any other variables that might impact the relationship. So let's look at transmission out of curiosity. We either have automatic or manual. So we can drag transmission to the middle of our graph and drop it, and it's going to color our points yellow if they're automatic and purple if they're manual transmission. And now we can see we have different lines for automatic and manual transmission, and we can see manual has a slightly less steep slope and automatic has a little more steeper slope. Now, why might this be? Well, I can see up here that my automatic transmission has more data points in this range where there are no other manual transmission points. So that might be pulling the line up towards those a little bit. Let's click on them and see what happens. I think that hybrid might have something to do with it, because we can see that all of these cars up here, yep, we get a yes for hybrid in the table. Yes for hybrid in the table again. Yes. Okay, so I think hybrid might have something to do with it. So now I want to look at something new. So let's take off transmission, remove it from our graph, and we're going to come up here and remove our least squares line. Okay. Now let's come to the table, and let's click on this little plus sign and add a new attribute called residual city MPG. Okay. Click on what we just created. Click Edit Formula, Insert a Function, Statistical Functions, and we're going to look for linear regression residual. All right, let's click on that, and we're going to fill in these spots. So for our x expression, we're going to put engine displacement because that's our variable on the x-axis, and we're going to put city fuel economy there, and we're going to take out our filter because we don't need one for what we're doing right now. Click Apply. Okay, now we have all of these entries for our residual. So let's replace our city MPG on the graph with our residual variable that we just created. Now we can see the distance of each point from the regression line between engine displacement and city fuel economy. So this x-axis is just like the regression line we had in our other graph. And now we can see all these hybrid points up here that are hanging out that kind of don't fit our data, because they're all automatic transmission and they all have a higher fuel economy than we would expect. Okay, but for the other points, most of these aren't hybrids and they hang around 0 just like we would expect. So in the future investigation, we would consider taking into account hybrids to adjust for predicting our fuel economy based on engine displacement.